Hey guys, it's Mr. Sheline. I wanted to make this video to continue to help you understand how to solve and to balance these equations. I've got two examples here. I've got a fairly simple one ready to go right here, and then a slightly more complicated one that we'll finish at the end here. It's just to see, just to give you that extra practice to see how it is that I do things in real time. I've never worked on these problems before. As far as I can tell, so this is just live raw feed of me solving these with you guys. So again, it's just to kind of help you if you're already struggling, or if you're still struggling, or if you need that extra support. And on top of that, or I guess that's pretty much it. Sorry, I'm guessing this is going to be about a 10-minute video. It might run over that, but we'll see how long it takes. So okay, let's just jump right to it. Okay, so we've got iron is going to react with chlorine gas here, and it's going to result in having iron chloride. Specifically, it looks like it's going to be iron 3 chloride. Okay, doesn't matter which kind of iron, but just interesting, we can see that's going to be iron 3. Okay, so let's just break this down into our T-chart like we normally do. So I'm going to put E over here. I'm going to put number of atoms on the reactant side, and then my yield symbol, number of atoms on product side, and I'm going to make my lovely T-chart. And it looks like all we're working with is just iron and chlorine. Okay, so looking at my product side, it looks like I've only got one atom of iron, and over here it looks like I've got 2 atoms of chlorine. Okay, lovely diatomic guy right there. Okay. And then over here on the product side, I still just have 1 iron, but now I've got 3 chlorine. Okay, so I'm looking at this and I'm saying, well, it looks like, iron is ready to go. I don't need to mess with iron. But I'm looking at chlorine, and it looks like chlorine, I've got 2 and a 3. And in my head, I'm saying, okay, what's the lowest multiple of 2 and 3? And it's 6. Okay. So over here, I can change this guy to chlorine having 6 over here, and I can definitely change chlorine to 6 over here. So I'm going to do that. I'm going to put a 3 here, and that's going to change it to 6. And I'm going to put a 2 over here, and that's going to change that guy to 6. Okay. So my chlorines are now good, but now my iron has changed. So now it's 2 over here. So now this guy needs to be 2, and I just stick a 2 over there. And I am balanced. And it looks like I'm good to go. So it's going to be, all said and done, my balanced equation is going to be 2 Fe. It's combining with 3 Cl2s, which is going to yield 2 molecules or 2 formula units of iron 3 chloride. Okay, awesome. So that guy's pretty much done. Okay, so let's try something a little bit more challenging. Okay, so let's pull this guy out here. So we've got a hydrocarbon right off the bat. So it looks like this is somewhat going to be combustion, almost. Okay, so let's just take a look here, and let's just kind of see what we have, and then go from there. So, okay, so here's my reactant side, here's my product side. So let's just break this down. So my elements, and then number of atoms on reactant side, my yield sign match with this, number of atoms on my product side. I'm going to make my T chart, and it's going to be a big one because it looks like I've got carbon, hydrogen, another hydrogen, nitrogen, and oxygen. So we've got carbon, hydrogen. Make sure you don't draw hydrogen twice. We're going to count that guy with this guy, but don't count him twice. And then nitrogen, and then oxygen. Okay, just to double check, yep, that's all I got. So let's count how many of each we've got on both the reactant side and the product side. So on the reactant side, it looks like I've got 7 carbon, I've got 10 hydrogen, because I've got 9 here, and then 1 here. I've only got 1 nitrogen, and then it looks like I only have 3 oxygen. Then over on the product side, looks like I've got, just to double check, yep, I've got 7, still have 7 carbon. Looks like, and this is where we gotta be careful, looks like I've got 6 hydrogen here, and I've got 2 hydrogen over here. So that's going to be 8 hydrogen. And then this is where it gets tricky. So I've got, within this whole compound here, not only do I have to work with this guy, I also have 3 whole formula units. I've got 3 whole molecules of NO2, of nitrite. So we're going to factor in that 3. We're going to factor it into the O2 and also the nitrogen. So 3 times 2 is 6. But then I've got another oxygen out here. So that's going to be 6 plus 1. So that's going to be 7 oxygen. And then the 3 times the nitrogen there is going to be just 3. Okay, so this guy is pretty busy. Okay, really, really busy, in fact. So, okay, but it's really not that challenging. Once, hopefully you're already starting to see it based upon your, the practice you've already had. But let's just kind of walk through, those steps. So remember, there's that hint that you want to work with the one that's the least, the one that's least busy. Like they start with the element that's not in as many compounds. So we can already see that hydrogen is in 2 compounds on both sides. So hydrogen we're going to kind of leave alone because he's a little complicated. And even oxygen on the product side, oxygen is in 2 places, so we're going to leave him alone. Also, it's a 3 and a 7, so that's going to be a little tricky. So we're going to leave oxygen alone. We're going to leave hydrogen alone. But we do have nitrogen that's only here, and we also have carbon that's only in 1 compound as well. So it's going to be between these 2 to start with. But I noticed that my carbon here is already 7. And I can't really do anything with that. So I'm just going to start with my nitrogen, actually. So nitrogen seems like it's going to be easy to start. So it looks like I've got a 1 over here, a 3 over here. So I'm just going to change my nitrogen I'm going to change this guy to a 3, which means that I'm going to, and here's where I really hope you guys use, pencils. I'm just going to keep using my marker here, but I'm going to put a 3 up here and see what happens. Okay. So I've got a 3 there. That changes that to 3, but here's what else happens. So not only does it change my nitrogen to 3, it's going to change this hydrogen to 3. So then it's going to be 3 plus 9. So then that's going to change that guy to 12. And then also, we're going to factor in this 3 over here to the O3. So that's going to be 3 times 3, which is 9. So that's now going to be 9. Okay. So now things are a little bit more complicated, but it's fine. We'll work this out. So let's just take a look here. So carbon is still at 7. Hydrogen's now 12 to 8. Nitrogen's good to go, though. And then we've got oxygen here. Oxygen is at 9 to 7. Now here's something that's really cool. So this is something you really have to keep track of and something that you've got to look out for. Now notice, my nitrogen's fine. Okay, my carbon's fine. So if I look over here, what has carbon and nitrogen in it? And it looks like it's this guy. And because there's both my nitrogen and my carbon is in over here, I'm not going to be too worried about this dude. And I say that because I've got oxygen and hydrogen that are off. But I've got oxygen and hydrogen over here. So maybe there is something I can do with this guy that will change my number and basically just solve this whole shebang. So let's just see. Okay, so I need 4 more over here, and I need 2 more over here. Okay, so how could I do that? Well, let's just kind of focus in on hydrogen. So I need 4 more hydrogen over here, and I don't think I can multiply anything against this guy to give me 4 more with 6. I'm looking at this, and I'm saying, oh, definitely I could stick a 2 over here. And now I've got, instead of 2, I now have, I've got 2 over here. Let's just see what happens with that. So if I stick a 2 over here, so now I've got 6 plus 4, so that's 10. Well, we're getting there, and that's going to change, and that's going to change this guy. It looks like we've got, that's going to be 6, 7, and that's going to be 9. So it looks like, wait a minute. Here, give me a second here. Double check if my math is right. That should be 6, and then oops! I was going to say something was off. Yeah, it's going to turn that to 8. So I'm really, really close, but I'm not there yet. So let's just up this guy up by 1. Let's just see what happens. So instead of 2, let's try 3. Okay, so 3 times 2 is 6, and there's a 6 over here. So that now we've got actually 12 hydrogen. 3 times 1, I've got 3 over here. 3 times 2 is 6. So now 3 plus 6. Now I've got my 9. And just to double check here, just to make sure I've got what I need. So it looks like carbon is 7 to 7. Hydrogen is 12 to 12. Nitrogen is 3 to 3. And oxygen is 9 to 9. And it looks like I'm good to go. And so my balanced equation would be C7H9 reacts with 3 molecules of, looks like nitric acid, and then yields C7H6 NO2 3, and also produces some water, which is going to produce 3 molecules of water. And then we have our full balance, nice and easy, our full balance equation looking all good and sharp. All right, guys. Well, that's just a quick little rundown of real time how I figure things out. Maybe I'll intersperse the week with a couple more of these little videos to help you chug along, and optional viewing, I guess, is what it would be. So, anyway, I hope this helps. If you still have questions, make sure you ask me. Thanks for watching. I'll see you guys in the next one.